All right, in this video, we're going to go over the last problem that you'll see on your test, or maybe not the last one, but the last type of problem the last type of problem you will see on your test. So in this one, it says, suppose that the blood cholesterol level of all men aged 20 to 34 follows a normal distribution, cool information, with a mean of 188 milligrams per deciliter and a standard deviation of 41. Sorry, I was looking at this right here. It should either be, no, it shouldn't be that. It should be the fancy symbol for the population, but there was a typo. In a simple random sample of size 100, find the probability that X estimates the mean. Sorry, let's change this. X will be within plus or minus 3 milligrams per deciliter. So we're trying to figure out the probability that it's going to be between those two, or 3 less and 3 over. So let's go ahead and write out what we know. So we know that the population standard deviation is 41. We know that the mean of the population is 188. We also know that the sample size is 100. And we're also looking for the probability of plus minus 3 milligrams per deciliters. So number one says to calculate the mean and standard deviation of X bar for n equals 8. Go ahead and change that to n equals 100. That was copied and pasted over from your test. So it used the sample size from the test, not the review. Sorry about that. It says, hint, use the formula for a mean standard deviation. That's nice. So what we're going to do is we're going to start with mean. So the mean of the sampling distribution is going to be equal to the population distribution, that unbiased estimator. Then we're going to find the standard deviation of X bar. And the standard deviation for a sample mean is different because this is going to be the population standard deviation divided by the square root of the sample size. So we're going to do 41 divided by the square root of 8. When we do that in your calculator, you should get, sorry, not 8, 100. Goodness. Square root of 100, and you will get 4.1. And that's it. The next step says to justify that the sampling distribution is approximately normal. So because this is a mean, we are going to use the central limit theorem. So with the central limit theorem, the first thing we're going to do is figure out, is the sample size greater than or equal to 30? And in this problem, the sample size is 100, and 100 is greater than or equal to 30. So we're going to be like, yes, this is normal. Yay. If the sample size were less than 30, then we would look at the problem where it says that it has a normal distribution and just follow the population's distribution. So number 3, shade in the area that you are looking for. So I'm going to start by always putting the mean in the middle. And then I'm going to go back to the problem. And it said, what is the probability that it is going to be within plus or minus 3? So I'm going to go 3 to the left and 3 to the right. So this is going to be 188 minus 3 is 185. 188 plus 3 is 191. And we're looking for that area in the middle. We're kind of looking for that middleman. Okay. If you were to write this out because you really want to know what the probability is, you would put the probability that X is between 185 and 188. Okay. Now with this, because there are 2 values that we're looking at, that means we're going to have 2 Z values. So we're going to get to do the formula for Z twice, where the first one is going to have an X value of 185 and the other one's going to have an X value of 191. sorry. So we're going to find those two z values. So we're going to do 185 minus 188 divided by our sample standard deviation. And we're going to do the same thing on the other one and figure out what those two numbers are. So go ahead and plug those into your calculators. When you do, you will get negative 0.73 and positive 0.73. So remember, this number is actually going to be the same where one is negative and one is positive because we added and subtracted the same distance from the mean. And all the z-value tells us is how far away does the value fall from the mean on the standard normal distribution curve. So they should actually be the same number if you're doing it right. Unless it says 10 less and 5 over, these numbers are going to be the same. But because since we subtracted the same number to the left and to the right, that's why they're the same number. So we're not done. We get to find the probabilities in table A. Now, we're going to find not one probability in table A, but we're going to find two. We're going to find the probability that z is less than negative 0.73 and the probability that z is less than positive 0.73. So we're going to use our table. For the negative side, I'm going to go 0.7, 0, 1, 2, 3, and that's 0.2327. So 0.2327. And then we're going to do the same thing for the other one, and we'll get 0.7673. Okay. Now, in the table, these two numbers, so this is negative 0.73, and this is positive 0.73. From this line right here all the way to the end, that is 0.2327. However, from this line all the way to the end, that is 0.7673. And we need to find the area in the middle. So what we're going to do is we're going to subtract those two numbers. So where it says, what is the mathematical answer? That's just checking the shading and making sure that we have the correct final answer. So 0.7673 minus 0.2327 gives us a probability of 0.5346. And that will be our final answer. If you feel like we went a little too fast in this video, remember that YouTube has the ability to slow down a video. So if you need to rewatch the video, remember that you can just slow it down. I recommend not speeding it up because then it'll go really, really fast. Good luck on your test. Have a great day.